2.1 Relations and Functions. Before you finish the video today, you should be able to graph relations and identify functions. Okay, relations come in many forms. The first one we're going to talk about are the ordered pairs. That's the input, comma, output ordered pair like X, Y. And I'm going to give you the same ordered pairs for every different form of a relation. First, we've got -3, 4, 3, -1, 4, -1, and 4, 3. Then they want you to do a mapping diagram for that relation. And you'll do X, Y, or X is the input, Y is the output. Meaning you put the X into the function and you get the output out. So my X's are -3, 3, and 4. And that's just from here. My Y's are 4, -1, and 3. And then you draw an arrow for every ordered pair. So -3 to 4, 3 to -1, 4 to -1, and 4 to 3. So this mapping diagram represents this relation. Then you can also do a table of values, and again you would just do an XY column. The X is still the input, the Y is still the output, and you just put in your X's, -3, and your Y's, 4. So this ordered pair I just put in this table, and so forth. 3, -1, 4, -1, 4, 3. And again, this ordered pair went here, this ordered pair went here, and so on. And you can also graph it. So if you have to draw a graph, I'm just going to sketch one in this blank. But you are going to put a point for every ordered pair. So -3, 4, point there. 3, -1. 4, -1. And 4, 3. So that's the 4 different ways that they can represent relations. Example 1, the monthly average water temperature of the Gulf of Mexico and Key West, Florida varies during the year. In January, the average water temperature is 69 degrees Fahrenheit. In February, it's 70 degrees. In March, it's 75. And in April, it's 78. Represent this relation in 4 different ways. So since I'm talking about months, I'll just probably do like the number month. So January is going to be 1. February is going to be 2. March is going to be 3. And April is going to be 4. Represent this relation in 4 different ways. So first I'll do ordered pairs. That's going to be 1, 69. Then 2, 70. Then 3, 75. And then 4, 78. Okay, a mapping diagram, you're just going to do 2 bubbles. 1, 2, 3, 4, 69, 70, 75, 78. And they just go 1 to 1. Then let's do a table. So we'll do X. Actually, let's do month and temperature. So that's 1, 2, 3, 4 again, and 69, 70, 75, 78. And then we'll do a graph. Since the temperature never goes negative, I'll just do the first quadrant. We'll do 1, 2, 3, 4. And since it starts at 69, I'm just going to do this little squiggly line and start at 69, 70, 71, 72, 73, 74, 75, 76, 77, 78. Oh, I went too high. So it's 169, 270, 375. So that's 71, 2, 3, 4, 5, 375, and then 478. It's going to be way up here. And there's your graph. So you represent it in 4 ways. Okay, example 2, domain and range. The domain of a relation is the set of X values, or the input, and the range is the set of Y values, or the output. So when they ask you for domain and range of the relation, what I want you to do is do domain, and I just use the capital letter D, and I just list the x values. So negative 3, 0, 2, 9, and 23. And the range is 14, 7, 0, negative 18, negative 99. Set of x values, set of y values. Now let's talk about identifying functions. When you want to identify a function, you have to make sure that the x's are not used more than once. This says in a function each element of the domain corresponds with exactly one element of the range, which means x is only used one time. If you're looking at a mapping diagram, then only one line can be drawn from the x values. So for A, this one is a function. And then B, 4, 8, 1, 6, 4. 4 is used twice. I don't care about the y's, I only care about the x's. If an x is used twice, it's not a function. Like I know 6 is used twice for the y's, but that doesn't matter. It only matters if the x is used twice. Okay, example 4, the vertical line test. They want to know which graph represents a function. So I have a vertical line here. I'm going to take my vertical line and I'm going to pass it across the function. If it touches more than once at any point, then your graph is not a function. So I can stop it at any point on this graph and you'll see that I have 2 points where it touches. So this first one is not a function. Okay, B, going to take my vertical line and pass it across the graph. It doesn't matter where I stop it, it only touches one time at every point. So B is a function. And then C, again, I'm going to take my vertical line and stop it at where there's a point, and if there's only one point there, okay, my line's kind of chunky, but it still looks like those 2 points are right up on top of one another. And then that one stands alone. But these 2 points right here, because it touches at these 2 points, this one is not a function. Example 5, function notation. This equation right here is called function notation. F of x is your output, so in other words, it's your y. And they're going to give you some numbers to plug in for your input or your x to get your y or your f of x out. So really, you're just going to take each one of these numbers and plug it in for x. So the way you write it is you're going to say f of negative 3, which means a function of negative 3, and you're going to place your x with negative 3. What a lot of people think is that you multiply this and get negative 3f, but that's not true with function notation. That just means when you plug negative 3 in, you get, and then you simplify the right-hand side, this is going to be positive 6 plus 5, which is 11. Then we're going to plug in 0, so f of 0 equals negative 2 times 0 plus 5. F of 0, I marked that out because it's 0, and then 0 plus 5 is just 5. Now we'll plug in 1/4, so f of 1/4 equals negative 2 times 1/4 plus 5. That is going to be negative 1/2 plus 5, which happens to be 4 1/2. So my output is 11, 5, and 4 1/2. They could have also said, what is your range output if your domain input is this? Okay, example 5b, function notation. Again, I want you to take your domain, your input, and plug it in for your x and find out what your y is. So you're really essentially doing 3 different problems. F of negative 2 equals negative 4 times negative 2 plus 1. And all I did was replace this x in my function with the x from what they gave me, the first number in what they gave me. And then I'm going to do it again. F of 0 equals negative 4 times 0 plus 1. And then f of 5 equals negative 4 times 5 plus 1. And then we'll just multiply it out, and we get 8 plus 1, which is 9. So f of negative 2 is 9. I get 0 plus 1, which is 1. So f of 0 is 1. And then I get negative 20 plus 1, which is negative 19. So f of 5 is negative 19. And you can answer this way, or you could say that your input or your output is negative 19, 1, 9. Okay, got it. I want you to, on a separate sheet of paper, show all of your work and answer these 4 questions. Make sure you do an attempt on each question. Actually, there's no work to show here, but make sure you attempt each question and give me an answer for all 4.